Let's look at this problem from your lab assignment, section 6.4, problem number 4. When the gas expands in a cylinder with radius r, the pressure P at any time is a function of the volume. So we can write that as P is equal to P of V. The force exerted by the gas and the piston is a product of the pressure and the area. So the force is equal to F equals to pi r squared times P. The work done by the gas when the volume expands from V1 to V2 is given by this integral. So it's the integral from V1 to V2 of the pressure P dV. In a steam engine, the pressure and volume of steam satisfies this equation P times V to the 1.4 power is equal to K, where K is a constant. This is true for adiabatic expansion, that is, expansion in which there is no heat transfer between the cylinder and its surroundings. They want us to calculate the work done by the engine during the cycle when the steam starts at pressure of 150 pounds per square inch, and then the volume goes from 400 cubic inches and expands to 1,300 cubic inches. All right, there's a lot of information here. We gotta decipher it. So it says here we know that the PV is equal to K and the work done is equal to this. So that was given in the problem. The steam starts with a pressure 150 pounds per cubic inch. The volume is 400. The pressure is 150 pounds per square inch. The volume is 400 cubic inches, and it goes from 400 to 1,300 cubic inches. We're dealing with the work, and then we're dealing with pounds and inches, so it has to be translated to feet, so we need to convert to foot-pounds. We have 150 pounds per cubic inch, so this is in inches, cubic inches. We want it in, this is in square inches, we want it in square feet. So we need to multiply this by, so this is the integrating or the multiplying factor that we need. So we need to multiply this by 12 times 12. So 12 times 12, I think it's 144. And we have V1, the volume in 400 cubic inches is going to be translated to cubic feet. So our integrating factor for that, or our multiplying factor for that, is 12 times 12 times 12. So that's 12 raised to the third power, 1728. And then, so this is going to be the same as well, 1728. Okay, so we have P. Let's get all this down here. Our P is equal to, and this is 150 times 144, and so we got 21,600, and our V1 so V1 is equal to, here we have 400 divided by 1728. We can probably reduce that. I wonder if we should reduce it now or later. Or let's see, 400 divided by 1728. Doesn't fit nicely. Let's worry about that later. And then we have our V2 equaling to 1,300 divided by that same number. All right. Now we need to find K. So they want us to find K by taking our pressure P and multiplying it times V1 raised to the 1.4 power. So let's take our calculator out again. Our P was 21,600, and then we need to multiply V1. So I'll open my parentheses. I got 400 divided by 1728. Close the parentheses, and I want to raise this to the 1.4 power. It looks like we just have V1. I don't know what happened to my multiplying by P, the pressure, so let's just multiply this by the pressure. That's 21,600. Looks like we got a big value here. They want us to round off to 3 decimal places. So we got 2784, and then this is 6877. So our 4th decimal place is 7. That's bigger than 5. We're going to round up to 8. All right, that worked out. So if this is K, we're going to solve for P. So we're going to solve for P. We're going to have our K value, which we found, and then we're going to divide out by V to the 1.4 power. If we divide that over, it looks like this should be a negative 1.4 power. Your power goes negative if you divide it. It's like putting it in the denominator. Alright, so we have a function P, a constant times V raised to the negative 1.4. And so now we just need our integral. So we have V1, this is V1, 25 divided by 108. We need V2, which is 1300 divided by 1728. We could probably reduce that. We talked about reducing, but we didn't. Let's see if this will take the answer with an unreduced fraction. So it looks like it took the answer. The reduced fraction, if we're interested, is 325 divided by 432. Now we're going to do the integral. We have a constant that we can move outside of the integral, so that's what they did. We have this integral of v to the negative 1/4 dv. So we add 1 to the power. Now this is a negative number, so when you add 1, it goes. Well, you just have to make sure you add and not confuse the subtraction. So we're going to divide by that same number, so negative 0.4. And then they want us to work it out. Okay, so it looks like some calculator plugging in business. So let's do that. I have a scientific calculator. If you have a graphing calculator, that might work out nicer. So let's clear this. And we're going to start from left to right. Let's see if we can do this from left to right. We have 2784.688, and then we're going to multiply that by something. So in parentheses, I'm going to put a parentheses here and do the fundamental theorem of calculus. We have the antiderivative here. We just have to put in those values. So the first value we're going to put in, I'm going to add on another parentheses. I'm going to put in the 325 divided by 432, and I'm going to close the parentheses so I can raise this to the negative 0.4. So I think that's a 0.4 negative on this calculator. And then we're going to go ahead and divide that. Oops, let's divide that by negative 0.4. Okay, so that's the first term of the fundamental theorem of calculus. That's like capital F of B. Now I'm going to do a subtraction, and I'm going to subtract essentially the same thing. I'm going to open up another parentheses, and then for V, I'm going to put in the 25 divided by 108. Close my parentheses so I can raise this to the 0.4 negative 0.4 power, and then again I'm going to divide this by negative 0.4. So that's the second part of the fundamental theorem calculus. That's like f of a. And then I'll close the parentheses. Okay, so if you have a graphing calculator, you can do all this in one line and you can see it. I have a scientific calculator, but I can kind of see what I did here. So that looks okay to me. I'll press enter. I guess I don't have to because it's here. It looks like equals. It looks like it's 4,698. Round your final answer to 2 decimal places. So 4698.8856. How many decimal places? 2 decimal places. So I want to look at this number. This number is 5 or bigger. So I'm going to round up. And hopefully that's correct. Okay, so we did everything. This is really heavy on the numerics and your calculator, so be sure you type in the values correctly and plug in your calculator, maybe even do things on Wolfram Alpha so you can see all the steps kind of being taken in stride. I encourage you to do this on a piece of paper also, you know, just perform that integral on your own on a piece of paper and see how far you get. Okay, I hope that helps. Good luck.